Hello all, welcome to EC Electronics. So in this video, we will be doing the MCQ question on rectifiers. So we'll be doing this video as a mock test, especially for the AFCAT EKT examination preparation. A lot of people is going to write the AFCAT exam next month. So I'm doing this series of MCQ videos for various topics or subject wise for especially for AFCAT preparation. Okay, so we'll be seeing 10 questions in this video connected to the rectifier session. That is including half wave, full wave and center tap full wave rectifier. So please try to attend the question if you're preparing for AFCAT exam or any other competitive examination of electronics. Okay, and if you found the video useful, please don't forget to like, share and subscribe. Now let's see the 10 questions. So this is a MCQ video for rectifiers. So we have seen the 10 questions. Now we are going to see the solutions of the 10 questions. So this video I'm especially doing for the AFCAT examination. The examination is going to happen on the first week of next month, that is October. Okay, so let's see the solutions one by one. The first question is, you'll be seeing the questions on board. The diode in a half-wave rectifier has a forward resistance of RF. The voltage is Vm sin omega t and the load resistance is RL. The DC current is given by dash. So what all things have been given? The forward resistance is given RF, load resistance is RL, and the input voltage is Vm sin omega t. You need to find the value of DC current, that is IDC. So what is the equation for finding IDC? The DC current is equal to the P current or Im by pi. So this is the equation for finding the value of DC current. First you need to find what is Im, and the equation for finding Im is equal to, Im is the peak voltage, which is Vm by resistance. We know that current is equal to voltage by resistance. So since we are finding the peak value of current, it is the ratio of peak voltage to the total resistance. Total resistance is the sum of RF plus RL. So this will be your Im. Now Im by pi is the value for IDC. So it will be equal to IDC is equal to Vm by RF plus RL by pi. So it is into pi. Okay. So it will be, the equation is Vm by RF plus RL into pi is the value for your DC current, and the correct answer coming is option B. Okay. So if you want me to do a video on all the important equations of all type of rectifiers, that is half wave rectifier, full wave rectifier and center tap full wave rectifier, all these things, this will be including all the equations for the DC current, the voltages, the efficiency, peak inverse voltage, all these equations. If you want me to do a video, please do mention in the comment section. Okay. So this is the answer for the first question, which is option B. Moving on to the second question. Okay, second question is a theory question. The efficiency of a half-wave rectifier is dash. A 50%, B 60%, C 40.6%, D 46%. Okay. So the answer is option C, 40.6%. So the efficiency eta for half wave rectifier is equal to 40.6%. Now what is efficiency eta? Efficiency eta is equal to DC power output to the AC power input. So we know that in rectifiers, what is the basic process happening? In rectifiers, the AC values or AC is converted to DC, right? So the efficiency you can write is eta equal to DC power output. How much DC power we are getting by the AC power input. Okay, so this is the equation for finding the efficiency. Or you can say efficiency for rectifier is the effectiveness to convert AC to DC. How much effective is the rectifier in converting AC to DC? That is efficiency. For a half wave rectifier, it is 40.6, and for full wave rectifier, it is 81.2%. So in this video, maximum I will try to give you the information. And the other things, if you want me, I will do a separate video. Okay. So this is the efficiency values for half wave and full wave rectifier. For half wave, it is 40.6%, and for full wave, it is 81.2%. So here the correct answer is option C, which is 40.6% is the efficiency of a half wave rectifier. Third question. Third question is, if peak voltage of a half wave rectifier circuit is 5 volt and diode cut-in voltage is 0.7, then peak inverse voltage on diode will be dash. So what is actually a peak inverse voltage, or PIV? So PIV is the maximum reverse bias that can be appeared across a diode in a given circuit. That is how much maximum reverse bias can be applied across a diode. That is called peak inverse voltage. So if the PIV rating is less than the value of breakdown, the diode will break down. Okay, so if the PIV rating is less than its value of breakdown, the diode will undergo breakdown. Okay, so for a half wave rectifier, the equation for PIV is the maximum voltage Vm. PIV is given by Vm minus the voltage across diode. The built-in potential of the diode. So here maximum circuit voltage is 5 and the diode cut-in voltage is 0.7. So it will be 5 minus 0.7, which is equal to 4.3 volt is the PIV. Okay, so later on in this video, we will be discussing the PIV for full wave rectifier also. But for a half wave rectifier, this is the equation. Okay. And what is the difference from the full wave, we will discuss while discussing that question. Okay. So just know that for a half wave rectifier, PIV equal to Vm minus Vt. Here the Vm value is 5 and the cutoff voltage or the built-in potential of the diode is 0.7. So it is 5 minus 0.7, which is 4.3 volt. Correct answer is option C. Now, the fourth question. The fourth question is connected to the ripple factor. Again, ripple factor is a very commonly asked type of question. It is a theory question. It is a constant value. You should be knowing the ripple factor for all the type of rectifiers. Okay. So the question is, ripple factor of a half wave rectifier is dash. A 1.414, B 1.21, C 1.3, D 0.48. Correct answer is option B 1.21. Okay. So ripple factor for half wave rectifier is 1.21. Now, what is ripple factor? Ripple factor of a rectifier is a measure of effectiveness of a power supply filter in reducing the ripple voltage. How much effective the filter is in reducing the ripple voltage that can come to the output side. And it is calculated by taking the ratio of RMS AC component of output voltage to the DC component of the output voltage. Okay, so that is all the equations. That is how much AC component is actually present in the output DC. So the rectifier is actually converting an AC to DC, but still there will be some AC components present along with your output, which is an undecided thing. Okay, so this measure is called ripple factor. So for a half wave rectifier it is 1.21, and for full wave it is 0.482. Okay, so these are the values for half wave and full wave rectifiers, the ripple factor. Now this question is asking the ripple factor for half wave. So it is option B, which is 1.21. Okay. Next question. It is a fifth question. Fifth question is, in a half wave rectifier, the input sine wave is 200 sine 100 pi t volt. The average output voltage is dash. Okay, so how will you calculate the value of average output voltage? Average output voltage will be peak output voltage by pi. Okay, so the question is having a input voltage, input sine wave as 200 sine 100 pi t. Okay, so this is your input. If this is Vi, what will be Vm? Peak value of input will be 200. Now we don't need the peak value. The average, the question is asking average value of output voltage. Output average will be Vm by pi. That is 200 by pi, which is equal to 63.6619 volt. So correct answer is option D. Okay. So fifth question, correct answer is option D. Moving on to the sixth question. So the sixth question is, a full wave rectifier delivers 500 watt, there is a power, to a load of 200 ohms. The load resistance value is given. The power delivering is 50 watt. If the ripple factor is 2%, calculate the AC ripple across the load. That is how much AC voltage will appear across the load. That is the question. Okay, here. So what is the equation for finding the DC voltage? There will be some AC component present along with your DC voltage. That is the ripple, right? So first we will find what is the DC voltage. The equation is VDC is equal to PDC, the power by, the power, PDC power is equal to VDC square, V square by RL. This will be the equation for the DC power. Okay, here PDC is given, it is 50 watt is equal to VDC by 200 ohms, right? Sorry, there is a square. Yeah, from this, how will you calculate VDC? That is a DC voltage. VDC is equal to 50 into 200 whole raised to 1 by 2. That is, it is 100 volt. So the VDC is 100 volt. So in the question, you have been given the power and also the load resistance. Okay. So the DC power and the load resistance is given. So from that you can find the DC voltage by using the equation PDC is equal to V square, that is VDC square by RL. You will be getting the DC voltage as 100 volt. Okay. Also, the ripple value is given. It is 2% or it is 2 by 100. That is 0.02 is the value for ripple. Okay, gamma, you can take, that is, the ripple is represented using the letter gamma, 2 by 100, which is 0.02%. Now, what is the equation for ripple? Ripple is equal to VAC by VDC. That is how much AC component is present in the DC voltage. Okay. Here you know gamma, and also you know what is the value of DC voltage, and hence you can find what is the value of AC voltage present. So 0.02 is equal to VAC by 100, or you will get VAC, that is the AC voltage, as 0.02 into 100. That is 2 volt. Correct answer is option A. 2 volt is the correct answer for the 6th question. Okay, so how to do this question is, in the question it is been given the DC power and also the load resistance, and the ripple value is given, and the ripple value is given in percentage. So first you have to find, so the question is actually asking about your AC voltage value, that is how much AC voltage is present in the output, or along with your DC value or DC voltage, how much AC component is present is the question. So in order to find that, first you have to find what is the value for your DC voltage. And in order to find that, you can use the relation of power and voltage, that is P is equal to V square by R. By applying in that, you will get the DC voltage is 100 volt. Also, the equation for ripple is given by VAC to VDC. Here you have to substitute not percentage but the value, which is 2 by 100, which is 0.02. is the ripple value, is equal to VAC by VDC. VDC we already know, and then we will be finding the VAC or the AC voltage, which will be obtained as 2 volt, and the correct answer is option A. Moving on to the next question. The 7th question. If input frequency is 50 Hz for a full wave rectifier, the ripple frequency of it would be dash. This is a very famous question, or a commonly asked type of question. The input frequency will be given. You will be asked the ripple frequency at the output side, or the output frequency they will be asking. Okay. So for a full wave rectifier, your ripple frequency will be equal to your input frequency. This is the relation. Okay, for full wave rectifier, sorry, it is twice, not same, it is twice. Okay, so full wave rectifier, ripple frequency is equal to twice input frequency. Okay, so this is the relation. And for half wave rectifier, your ripple frequency is equal to input frequency. It is same as your input frequency. Please note these equations. It is very useful. Okay. So the relation between the ripple frequency and input frequency for a full wave rectifier is that if your input frequency is 50, then your ripple frequency will be twice of it. That is 2 into 50, which is 100 Hz. Whereas if this is a half wave rectifier, then the ripple frequency will be exactly same as that of your input frequency. So here the question is connecting to a full wave rectifier, and it is twice. So if the input frequency is 50, means the ripple frequency will be 2 into 50, which is 100 Hz. Okay, so correct answer is option A. So please note this equation. Okay, then the 8th question. The 8th question is from TUF, or transformer utilization factor. Again, a theory type of question, and also you should be knowing the values for half wave, full wave, and also for bridge rectifier. Okay. So the question is, the transformer utilization factor of a center tapped full wave rectifier is dash. So before seeing the answer, what is actually TUF, or transformer utilization factor? So the transformer utilization factor is the ratio of AC power delivered to load to the DC power rating. Okay. This factor is actually indicating the effectiveness of transformer usage by the rectifier. How much effectively the transformer is getting utilized, or how much effectively the transformer is being used. That is the TUF value, or transformer utilization value. For a half wave rectifier, the TUF value is, for half wave, it is 0.2865. Okay. Then, for a center tapped full wave, rectifier, its value is equal to 0.672. Then for a bridge rectifier, its value equal to 0.8106. So these are the values for half wave, center tapped full wave and bridge rectifier. Okay. So the question here, it is asking the TUF for center tapped full wave rectifier, it is equal to 0.672. But if you see the options are 0.623, 0.678, 0.693 and 0.625. So the value coming close is option B, which is 0.678. Okay, actually it is 0.672, but it is given in the options as 0.678. So we will be selecting the option B. So 8th question, correct answer is option B. Next, moving to the 9th question. The 9th question is again connected to the PIV, or peak inverse voltage. The question is, if the peak voltage on a center tapped full wave rectifier circuit is 5 volt and diode cutting voltage is 0.7, the peak inverse voltage on diode is dash. So here the PIV question is connected to the center tapped full wave rectifier. So before answering the question, you should be knowing that the peak inverse voltage in case of half wave rectifier is actually equal to the, or equivalent to the maximum value of applied input voltage. So for the case of half wave, what was the equation we have used? For half wave, we have used the equation TIV equal to Vm minus Vd. That is, it is the maximum value of applied input voltage and also minus the diode cut-in voltage. But for the full wave and center tapped full wave, the PIV is equal to twice the maximum value of your applied input voltage. Okay. So while the peak inverse voltage of full wave rectifier is twice the maximum of applied input voltage. So here we are going to use the equation 2Vm minus Vd. So for both the cases, we have to subtract the cut-in voltage of diode, but here we are taking the twice maximum of input voltage for full wave, and for half wave we are going to take the equation simply Vm, or the maximum input voltage. Okay, so for this question the answer will be PIV equal to 2 into 5 minus 0.7, that is 10 minus 0.7, that is 9.3 volt. So the correct answer coming is option B. Okay, so these are the two equations for half wave and for full wave. So this question is connected to the center tap full wave rectifier. So you have to use this equation. And the answer coming is 9.3 volt, which is option B. Moving on to the 10th question, which is the last question. The 10th question is, in a center tap full wave rectifier, the input sine wave is 250 sine 100 t. The output ripple frequency will be dash. Okay, so this question is again connected to the ripple frequency, but it is directly not given the input frequency. The equation of the wave is given. So what is equation of Vi? Vi equal to 250 sine 100 t. Okay. So this is your input sine wave equation. So from this, how will you find the input frequency? Here 100 t is nothing but 2 into Fi into pi. that is equal to 100 pi. Okay. So what will be Fi? Fi is equal to 100 by 2. So this is 2 pi ft it is given, or 2 pi f is given. So from that f you have to find, that is Fi or f you can find by taking the value here by 2, okay, which will be equal to 50 Hertz. So again, this question is connected to the full wave rectifier. So what will be the relation? Ripple frequency is equal to twice the input frequency. So if it was a half wave, then it is same. So we have already discussed the equation or the relation between ripple frequency and input frequency for half wave and for full wave. Here the question is connected to the full wave. So it is 2 into 50, which is equal to 100 Hertz. So this question is actually very similar to the previous question which we have answered. Only difference is that in this question, we are not being directly given the input frequency, but from the sine wave equation, we have to take the input frequency. In the earlier question, the same value was the frequency 50 Hertz, but it was directly given. Okay. So this type of questions will also come. You'll be given the equation for sine wave. From that you have to take, or you have to extract the value of frequency and then find the ripple frequency. And also the relation is for a half wave, it is same. Ripple frequency is same as input frequency, whereas for full wave, it is the twice of your input frequency, which is 2 into 50, which is 100 Hertz. Correct answer is option B. Option B, 100 Hertz is the correct answer for the 10 questions. So these are the 10 questions which I have included in this video. I'm again repeating that if you want me to do a video on all the important terms and equations of all the rectifiers, please do mention in the comment section. We'll be doing a video as soon as possible, okay? And if you found this video useful, please don't forget to give it a thumbs up and also share it with your friends. And if you want more videos, please do subscribe to the channel. Thanks for watching and keep on watching.